Hello everyone, myself Amandeep Randhwa. I am working as an assistant professor in Access Colleges, and my today topic is the introduction of pharmaceutics subject in D.Pharm, Diploma in Pharmacy, with the code is ER 2011T. Right. So today we will discuss only the introduction of the syllabus which we cover in pharmaceutics subject. So let's first talk about what is the scope of this subject pharmaceutics. Thus, in this, we gonna teach the students the art and skill, how to formulate and how to dispense the various dosage forms, right? Various dosage forms means the types of dosage, like tablets, it may be capsules, it may be injectables, it may be syrups, and how to formulate the formulation, the manufacturing process, how we gonna prepare the different dosage forms. It will come under the topic of formulation. And dispensing means after formulating the formulation by referring any pharmacopoeia. There are different pharmacopoeias like Indian pharmacopoeia, United States pharmacopoeia, British pharmacopoeia, national formulary. And by referring these pharmacopoeias, we're going to formulate different dosage forms. And after we formulate the dosage forms, then we have to dispense also. In dispense, we means the labeling and packing. What are the various procedures of labeling? What are the various types of packings? That depends upon the dosage form that we have prepared. And what is the course objective? Course objective in this pharmaceutics topic, the students must know how to formulate the various dosage forms, how to dispense the various dosage forms, the what are the packaging, how do we pack different dosage form, and what should be write in labeling, what are the different steps in labeling that it should cover, right? It may have instructions also in the labeling. That depends on the type of dosage form. Then the basic quality control test. It means after formulating the product in any production unit, right? Before going into the market, the product should comply all the quality assurance needs, the GMP needs. It has to prove that the formulation is of very good quality, it is efficient, it is pure. So there are different type of quality control tests are there, like dissolution test is there, disintegration test is there, friability test is there, right? So any formulation have to comply all these uh, tests before going into the market. And what are the various tests that we're gonna discuss in this subject pharmaceutics? Now, what is the course outcome? It means after successful completion of pharmaceutics subject, which is of 1 year duration, the student must know all the formulation criteria, all the dispensing criteria, and all the tests also. The advantages, disadvantages of different formulations as compared to other formulations, right? So this must the student must know. So there are basically 7 units which we cover in pharmaceutics in D.Pharm first year. So let's start one by one. In unit 1, there is a explanation of pharmacopoeia. What is pharmacopoeia? What are the different pharmacopoeias? And what after completion of D.Pharma course, what are the various career opportunities a student must be having? Then there is introduction also, like these are the various fields, means after completion of D.Pharma course a student can pursue. He or she may opt academics, he or she may opt production as then as a hospital pharmacist. So there are so many options are there, right? Which he or she may opt. Then in unit 2, we discuss about packaging materials. What are the basic types of packaging materials? Plastic, metal, paper and board, rubber. So these are the various packaging materials. And what are the advantages and disadvantages of each packaging material as compared to the others? So there is a whole description of these different packaging materials. Like in this slide, we discuss about the types of packaging. Three types of packaging are there: primary packaging, secondary packaging, and tertiary packaging. Primary packaging means, as this diagram is also showing, primary packaging means the drug is in direct contact with that packaging material, right? As this diagram shows, it's a tube of dental toothpaste is there. So the toothpaste comes in direct contact with that type of packing is called primary packing. And then we have secondary packing, and then we have tertiary packing. It's also called transporting packing or carton packing. Now let's go to unit 3. It covers all the pharmaceutical aids or excipients which we are using to formulate any pharmaceutical dosage form, right? In any pharmaceutical dosage form, there are two important things. First is API, that is active pharmaceutical ingredient, and second is the excipients or pharmaceutical aids. They both are synonyms. So what are the different pharmaceutical aids? What are the classification of it? Organoleptic agents are there. Organoleptic means coloring agents, flavoring agents, and sweetening agents. And the important thing is that all the excipients have no therapeutic value. They only help to formulate any dosage form. That's why the term comes aids. Aids means to help to formulate any dosage form. And second is preservative. What type of preservatives are there? How many types of preservatives? Natural, artificial, or whatever. So there is also full description of preservatives also. Preservatives main work is to preserve the formulation what we have formulate, to keep on that of its shelf life, the to keep its stability up to its shelf life. That is the main role of preservative. So this is the definition of pharmaceutical aids, as I have discussed earlier also. So these are the types of pharmaceutical aids. Plant origin are there, animal origins pharmaceutical aids are there, and mineral or synthetic origin pharmaceutical aids. Now let's come to unit 4. It covers, it's a very large unit. It covers the size reduction, size separation, mixing, filtration, drying, and extraction. So it covers so many topics. So let's go one by one. The first is size reduction. It means that to any formulate a dosage form, what we have given a drug in a bulk form. So to convert in any dosage form, first we have to reduce its size, right? So there are two types of mills are there in your syllabus. First is hammer mill, second is ball mill, which we are using to reduce the size of bulk material. Then comes size separation. In size separation means after reducing the size of bulk drug, then we have to very specific about the size separation. In any pharmaceutical dosage form, there are indications of what size of particles you gonna use to formulate that dosage form, right? And that type of particle size we can collect by the use of separate machines, which comes under topic of size separation. Like cyclone separator is there, sieve separator is there, sieve shaker. By the help of sieve shaker, we can get different grades of particle sizes easily. Then comes mixing. Mixing means, as the term indicates, there is a sort of combining of two or more ingredients. So it depends what type of ingredient is there. If solid ingredients are there, there are different mills. If all the ingredients are in liquids, there are different machines. If the ingredients are in mixed form, like some are solid, some are liquid, so there are different kind of machines. Then comes filtration. Filtration, as the term indicates, filtration is used for slurry only, not for solutions. Right? Solution is homogeneous. We don't need to separate anything from solution, but we have to separate it from slurry. Slurry is heterogeneous or biphasic. Then comes drying and extraction. So there are two mills which we discuss in pharmaceutics for D.Pharm first year in drying. Like two dryers are there. We have fluidized bed dryer, and second one is freeze dryer or lyophilization. Lyophilization is a synonym of freeze dryer. And then comes extraction. So these are the four basic mechanism of size reduction. Mechanism means principles on which the machine is working. Four principles, what are the names? Impact, attrition, shear, or compression. These are the four basic mechanisms on which any machine for size reduction is working. Now let's talk about hammer mill. Hammer mill works on the principle of only one mechanism, that is impact. Right? As the figure shows, it has several hammers are attached, and it rotates in a motion with RPM 8,000 to 15,000 RPM, very high RPM, and it is used for particle size for 10 to 400 nm. So this ball mill works on the principle of impact and attrition, as I have told earlier also. It works on the RPM of, its RPM is low as comparison to hammer mill, because if this machine works slowly, the balls will remain at the downward side, it doesn't go upward. And if we increase the speed to maximum level, then what happens? There is a centrifugal force acts on the balls, and the balls will stick on the inner wall of the container or cylinder. So size reduction doesn't take place in low speed or high speed. The size reduction only takes place in optimum speed. Now there is another mill called triple roller mill. This mill is used for semi-solid preparations. Means the ingredients, some ingredients are solid and some ingredients are liquid. For semi-solid preparation, we use this type of machine. It's called triple roller mill. So there are two conditions in this triple roller mill. First is the three rollers, as it is having three rollers, all the three rollers are rotate in different speed and in different direction. So in the third roller, a scraper is attached. What it does? Worker is there or pharmacist is there to ensure the texture what he is expecting. When it comes, it will scrap the semi-solid cake from the third roller and collect it. Then comes turbine mixture. Turbine mixture used for liquid mixing. Right? It means all the ingredients are in liquids. Two or more liquids are there, and we have to mix that those liquids. So we use this turbine mixture. In this circular disc is there, and on circular disc several blades are attached, like the figure also shows, and it works on the RPM of 50 to 200 RPM. It is used to mix emulsions or suspensions, like these are heterogeneous or biphasic liquid dosage forms, and syrups also. So these are the basic terms which are used in filtration. First of all, filtration is used only for slurries like suspensions, not for solutions. Because in suspension, the solid ingredients or solute are in undissolved form and they remain suspended in the solvent. So we have to get rid of that solute. What we do basically, we filter it. So this is a beaker which is showing it is having suspension. It means it is a slurry. So when we pour this slurry, there must be a filter medium to separate that solute from that solvent molecules. So here we can use any filter medium like filter paper that we used in lab. Filter cloth is there, cotton wool is there, glass wool is there, that we will discuss later. Then after filtration, what remains, filter cake remains on the filter medium, and at the bottom we get clear filtrate. Clear means it doesn't mean that if the slurry is in any color we get colorless filtrate. No, no, we means we get clear filtrate means the filtrate is not having any solute particles, right? All the solid particles remain on the filter medium. So by this we can easily separate out our clear filtrate. Now these are the various filter media that we used in pharmacy. As it shows, first is having filter paper that we're gonna use in our labs also. The filter paper is there, Wattman filter paper is there. Then comes cotton wool, then comes glass wool. Now what is glass wool? They are the very fine fibers of glass. Why? Because some slurries are acidic in nature, very alkaline in nature. They may disrupt the our filter media. So the glass fibers then we use, because glass fibers has melting point is around 1500 degrees Celsius. So any corrosive material cannot harm our this filter media made up of glass wool. Then comes asbestos, fine muslin cloth, filter cloth, membrane filter. This is used to get rid of all the microorganism, and we get our filtrate that is sterilized. Because to get any sterilized formulation, either we have to heat it to kill all the microorganisms, the disease causing pathogens, or we can do that we get rid of those all the pathogens from our solution, from our formulation. So to get rid of that, we may use membrane filter. The pores of membrane filters are smaller than the microorganism. So easily we can separate all the microorganism, and what we get in a filter is sterilized clear filtrate. Now this is sintered glass filter. Its mechanism is also same as of glass wool. We can use it, filters corrosive type of slurry, and we can use vacuum also in this sintered glass filter because it is very tough. It cannot break easily, right? We can use vacuum, and what vacuum does, it enhances the rate of filtration. So in unit 5 we covers mostly all the dosage forms like tablets, capsules, liquid oral preparations, topical preparations, nasal preparations, ear preparations, ophthalmic formulations, injections, eye drops, like that, sterile formulations, and immunological products also, vaccines type. So this is also a very big unit. So let's go one by one. In tablets, different types of tablets we cover. Coated tablets are there, uncoated tablets are there. Uncoated tablets we can also call it by conventional dosage form or immediate release dosage form, that is IR by the short name. Then we have various modified tablets. Modified tablet means that we have controlled the rate of disintegration of tablet, the to achieve the sustained effect of that dosage form. We can reduce the dose also by the help of modified tablets. If conventional tablet, the dosage is BD or TDS. So in this various modified tablets, we can reduce the dose to OD, once daily. So different modified tablets are there, like sustained release tablet. by the short name of SR tablet, we call it. Then we have extended release tablets, ER tablets. Then we have this fast dissolving tablets by the short name of FDTS. We call it as fast dissolving tablets. So these are various modified tablets what you wanna learn. Then comes hard and soft gelatin capsules. Capsules are of two types, either hard gelatin or soft gelatin. What is gelatin? Gelatin is a protein. Uh, from where it comes, from where we obtain gelatin? By the hydrolysis of collagen. Collagen is a protein which is found in the skin and bones of animals or human beings also. So by this we collect gelatin and formulate into hard gelatin or soft gelatin capsules as per the requirement. And what are the differences between hard gelatin and soft gelatin capsules? What are the dosage forms which we basically introduced in hard gelatin or soft gelatin capsules, and what are their sizes also? Then comes solutions, syrups, elixirs. These all are come under the category of monophasic dosage, monophasic liquid dosage form, because it has only one phase. And we have biphasic liquid dosage forms like emulsions and suspensions, then dry powders. Then we have semi-solid dosage forms like ointments, creams, gels, and paste. Four semi-solid dosage form what we cover in semi-solid dosage form category. Then powders, simple powder is there, compound powder is there. What is the difference between them? What are the different dosage forms of powders? Like insufflations are there, right? Effervescent powders. But now, what is effervescence? The releasing of CO2 by the chemical reaction. And what are injectables? Eye drops. It comes under the category of parenterals. Parenterals have two forms. It may be injectables, all type of injectables, or ophthalmic products. Ophthalmic products means which are used to install in the eye. It may be eye drop, it may be eye lotion, it may be eye ointment, it may be contact lens solution. Then, of course, the immunological products like sera, vaccines, what are them, what are their definitions, and what are the different dosage forms. So this is the whole classification of solid dosage forms, liquid dosage forms, or semi-solid dosage forms. Like solid dosage forms, it further breaks in two parts: unit dosage forms or bulk dosage form. Unit means single, bulk means of uh, good quantity, more quantity, large quantity. In unit dosage form, we cover tablets. So in tablets, what are the different types of tablets? Like I have discussed earlier also, there are conventional tablets and there are modified release tablets. What are the classification of it? Then comes capsules, types of capsules. Then comes powders. What are the different dosage forms which covers under powders and pills? So this whole category comes under the single umbrella of unit dosage forms. And bulk means more. It further divides in two parts: internal and external use. Internal, now what is the difference between internal and external? Internal means any dosage form when we swallow, it calls internal. And what is external? Any dosage form which we do not swallow. We may apply topically or in the mouth cavity only, not to swallow. So in internal dosage forms, there are fines, powders, granules, and in external dosage forms, we have dusting powders, insufflations, dentifrices. Dentifrices means tooth powder and toothpaste, right? We don't swallow tooth powder, toothpaste. We only apply on the teeth. So next category is liquid dosage forms. It further divides into monophasic liquid dosage forms and biphasic liquid dosage forms. Biphasic has two only: emulsion and suspensions. Emulsions, it may be either oil in water or water in oil, and by the help of emulsifying agent, we gonna stable that emulsion. And what is suspension? Suspension means the solid particle, the undissolved solid particles in solvent is called suspension. And how to prepare suspension? What are the ideal requirements of suspension or emulsion? So this we gonna cover in this topic of emulsion and suspension. Now, what is monophasic liquid dosage form? It further divides into two forms, internal and external. Internal means we have to swallow that internal dosage form, right? So it covers syrups, elixirs, linctus, and drops. So what are what are the advantages, disadvantages, and uses of them that we're going to cover in this topic? And what is external monophasic? It comes uh, as I have explained earlier also. External means you have to apply it topically on the skin, like liniments, lotions, gargles, mouthwash. Gargles, mouthwash need not to apply on the skin. They have to take in the mouth, but spit it out after its use. You need not to swallow it. That's why it comes under the category of external, right? Now, third category is semi-solid dosage forms. It again further divides into two parts: internal and external. Internal means some suppositories and pessaries. What are these? Then external: ointments, creams, pastes, and jellies. Four types. So this is the whole classification of different dosage forms. Now these are the various specs of different dosage forms, like tablets, capsules, lozenges. How it looks like. This is dentifrice, as I have discussed earlier also. Dentifrice, it covers tooth powders and toothpaste. Now let's go to sterile formulations. Sterile formulations, all the parenterals, injectables, what are the different types of injectables are there? That depends on which layer you are inserting it, which layer of skin, right? As this diagram is showing, this diagram shows the structure of the skin, epidermis, dermis, right, subcutaneous, like that. So in any layer, if we are inserting an injection, its name occurs. Like we have several injections by the name of IV, intravenous, subcutaneous, intramuscular. So different types of injections we're going to cover in this topic. Sterile formulations. Now this is the ophthalmic products or ophthalmic formulation, different types, like eye drops, eye lotions, eye ointments, eye solutions, and contact lens solutions. So in this we have to cover, right, the structure of the human eye. Once we know the structure of the human eye, then we can easily understand the different dosage forms of ophthalmic products. So these are the various images of ophthalmic products. So in unit 6, we cover the basic structure layout section of pharmaceutical manufacturing plant under the name of CGMP, that is current goods manufacturing practices. So in this CGMP means if a person want to establish or open her own manufacturing unit, what will be the layout of that unit, right? There must be uh, admin office, there must be a place for production unit. That depends what type of dosage form you are producing in that production unit. It may be tablets, so there are different, you know, criterias or rules regulations for the infrastructure for solid dosage forms, different for liquid dosage forms. What machine you gonna kept in what place, that is the suitable place for that machine, so that the worker may use that or operate that machine very easily. So there are the various different criteria for establishing any production unit, which comes under the category of CGMP that we're gonna cover. So this is the definition of CGMP. What is CGMP? It comes under in 1906 by USFDA. Now in unit 7, we're gonna cover novel drug delivery systems. In short, we say it as NDDS. Now, what is the term novel means? Novel means if we could control the rate of disintegration of the tablet, right? The rate of dissolution, if we can control, uh, then the dissolution time, and by this we can decrease the dose, right? So it comes under the category of novel drug delivery system. By this, ultimately, we are decreasing the dose, and secondly, we are improving the therapeutic level of that API or drug. by controlling the rate and by giving the path from at particular site it gonna act. So this is novel. So it improves the therapeutic effect, it controls the release, it decreases the dose and decreases the side effects also. So this is the classification of NDDS, what we are covering in NDDS: transdermal DDS, controlled DDS, implantable drug delivery system. Right, we are having various liposomes, phytosomes, nanoparticles are there. What are their sizes? What are the difference between them? What are the different, drug delivery systems are there in novel drug delivery system? So this is also very big topic. So we're gonna cover that also. So by this I conclude. So it was an introduction of pharmaceutics subject in D.Pharm first year, the whole syllabus. Thank you.